Welcome back to the SysML v2 deep dive series. In the previous lesson, we used specialization and redefinition to create a more specific model without changing its general definition. In this lesson, we will define how many instances of a feature the model allows. This is multiplicity, which acts as a structural constraint on the allowed cardinality, or the actual count of occurrences, of a feature. In SysML v2, multiplicity is written directly in a feature declaration with square brackets. A system model is incomplete if it says that a truck has wheels but never says how many. Does it have 1 wheel, 4 wheels, 18 wheels, or an unbounded collection of interchangeable modules? In SysML v1, multiplicities were represented either visually on association ends or textually inside block compartments as property strings. SysML v2 makes that cardinality part of the textual declaration. A model can state that a truck has at least 4 wheels between 2 and 4 doors, an optional sunroof, and any number of cargo boxes. That makes the design intent readable where the feature is defined. It also gives a specialized model a clear rule for how it may narrow a general model's allowed counts. Every feature, including a part, port, attribute, or item, has a multiplicity. It constrains the number of values or occurrences that feature may have. Square brackets 4 means exactly 4. Square brackets 2.4 means 2 through 4, inclusive. Square brackets 0.1 means optional. The feature may be absent or may have 1 value. Square bracket asterisk is shorthand for square bracket 0.asterisk, meaning 0 or more. For attribute, item, part, and port usages owned by a definition or usage, the usual implicit multiplicity is 1.1, when there is no explicit multiplicity, subsetting, or redefinition. In other situations, the effective default can be 0.asterisk. And if your feature subsets or redefines an existing feature, it automatically inherits the multiplicity of that parent feature. The practical lesson is to write brackets whenever the count is meaningful to the design, especially for ranges, optionality, and redefinitions. Here is a generic truck definition and a specialized heavy hauler. Feel free to follow along with a free account on SysModeler.ai. Let's walk through it. The truck definition starts with its wheels. This is a part usage named wheels, typed by wheel. Its multiplicity has a lower bound of 4 and no upper bound. A conforming truck must have at least 4 wheels, but the general definition intentionally allows a specialized truck to have more. The next feature uses a bounded range. A truck can have 2, 3, or 4 doors. The brackets make that configuration rule explicit instead of leaving it to a drawing convention or a separate property setting. Optional features use a lower bound of 0. Each truck may have no sunroof or trailer, or it may have 1. It cannot have 2 because the upper bound is 1. For cargo, we use the unlimited form. Asterisk means 0 or more cargo boxes. The ordered keyword says their order matters. By default, a multi-valued feature is unordered and unique. Use ordered when position matters, such as a sequence of packets, and use non-unique when duplicates must be allowed. Finally, the specialized heavy hauler narrows the inherited wheel multiplicity. The greater than operator redefines the inherited wheels feature. Square brackets 18 fixes its cardinality at exactly 18. This is compatible with the parent range of 4 to asterisk, because 18 is one of the counts the general truck allows. Redefinition can narrow multiplicity, not widen it. If a parent feature were fixed at 4, a child could not redefine it as 2 to 6. The new lower bound cannot be lower than the inherited lower bound, and the new upper bound cannot be higher than the inherited upper bound. Multiplicity is a concrete model constraint, so tools can check it. They can flag an instance or configuration that has fewer wheels than the lower bound, more doors than the upper bound, or multiple trailers where the model permits only 1. They can also check redefinition compatibility. In this example, 18 conforms to 4 to asterisk. A A redefinition that expands the set of permitted counts beyond the inherited range would violate the parent's constraint. Before we wrap up, here is the shift in compact form. In SysML v1, property multiplicities were often treated as secondary text labels rendered on diagrammic relationships. In SysML v2, the multiplicity is a first-class structural constraint that travels natively with the feature's textual declaration. Ordering is also expressed directly in the language with ordered, rather than a brace-delimited property modifier. Optionality keeps the same familiar 0-1 idea, but SysML v2 writes it in normative square brackets. Finally, do not assume every omitted multiplicity means 1. The 1.1 default applies only to qualifying structural usages, while other contexts can have an effective 0. default or is inherited directly from the specialized parent. We can now model exact counts, ranges, optional components, unlimited collections, and specialized configuration that safely narrow an inherited multiplicity. In the next lesson, we will move into attributes and the ISQ library, where values such as mass and power gain the physical quantities and units that engineering models need. See you there.